Hello, I welcome you all to this another interesting screencast. The problem reads, determine the horizontal and vertical components of force that the pins A and B exert on the two-member frame set F equal to 0. Okay. This problem is coming from the engineering mechanics statics 13th edition by R.C. Hibbeler. Right, so let's draw the free body diagram. This is equal to 0. So if this is equal to 0, then this member here is a two-force member, right? Okay. So this member is a two-force member. Because F is equal to 0, member BC is a two-force member, right? Okay, so now let's draw the free body diagram quickly. So we are going to have the reaction at A like so. Okay, and then we'll have another component there like so. Then we'll have another component there like so, and another one like so there. But we know here to say this is a two-force member, so here it is as good as the two-force member will be acting directly like so, in that direction like so. Let me draw that line. So I only expect one force there because this is a two-force member. I only expect one force like so. Let me put this, which will be in that line. Okay. Two-force member only has two forces that are collinear and opposite in direction, right? And they are collinear, okay, connecting the 2 points. Okay. So let's assume the reaction is in compression. Okay. Right, so here I only expect one reaction force like so. Okay, I'll call it B. Alright, I'll call this B. Okay, and then what else? And then let me call this here, this slope here. This slope here is 1 to 1. Okay, so I have a slope here. I have this slope, a 1 to 1 slope. So this is 1, right? This is 1. And this is 1 squared plus 1 squared, which is just root of 2. Okay, is that okay? Yeah, so we are going to have components here. We have one component of B. We're going to have one component like so, there like so, and then the other one like so. So each component is going to be, this is going to be B by 1 root 2. This one is B by 1 root 2. Okay, and then we are calling this as our AX and this is our AY, right? And then what else do we have? Of course, this is our coordinate system. This one here, this is our coordinate system. So let's call this as our Y and this is our X. So of course you can dismantle it, but there is really no need at this point, I think so. Since we are just interested in finding the reaction at A and B, we can go ahead with this particular way. Okay, so I'm going to take moments about point A. Here I'm going to have an equivalent force which will be acting mid-span. I'll have an equivalent force acting mid-span there. This distance from A there is going to be equal to 0.75. Okay, so let's call this 0.75. That's half of 1.5. And then this force here is, this one here is 400 times the length. Okay, this is 400 by the length by 1.5. Okay, this is the force here. So this is the magnitude of this load here. All right. Okay, so with that, I'm going to take moments about point A so that I find B. And once I find B, then I'm going to again take summation of forces in the Y and in the X. So we'll say summation of forces, summation of moments about point A equal to 0, and clockwise being our reference. What do we have? We have clockwise, which is negative, so we'll have 400 by 1.5, 400 by 1.5 by 0.75. Okay, this is moment about, this is due to this particular force there, which is clockwise, taking moments about point A. And then we have plus B by 1 root 2. Okay, this one by the lever arm. Lever arm, we are going to have 2 here. Let me just indicate another one here. So we have this one there and this one, like so. Okay, and then we'll have so we'll have this. Okay, and then we have yeah, just this. I think we need this. So this one is just equal to 1.5 by, sorry, this one is 1.5 by cos 60. Okay, so b 1 over 2 by the length, which is just a 1 plus 1.5 cos 60, and then this one is just going to be this length here. So I'll need to find this here, this length from there, sorry, from there to there. Okay, this, right, like so. So this one here is 1.5, this one is 1.5 sine 60. Okay, so then I'll say this other one here is also anti-clockwise, this one is anti-clockwise. So this, so we are looking at this distance right now. This is the distance that we are looking at. Just need to show it, this one here from there to there. Okay, this is the distance that we are looking for the other one, right? Okay, so let's call this as distance D. Okay, and this D, if we are to write it here, that distance D is just equal to distance D D is just equal to 1.5 sine 60 minus 1. So this one minus this, right? Okay. So here I'll say plus B again 1 root of 2 by D, which is this D here. Okay. What else? That's about it, then equal to 0. I know. Equal to 0, right? Yes, equal to 0. So let's find our, and then this one, we know what this is. We are going to replace in our D. So our B, therefore, if we were to calculate this, grab your calculator, you can do this. So we do have a clockwise, so it's minus 400 by 1.5 by 0.75, okay, and divided by okay, divided by 1 root of 2 times 1 plus 1.5 cos 60. There we go. We close this. So we had, all right, let me start with this. I think so. 1 divided by root of 2. All right, and then times, we have 1 plus 1.5 cos 1.5 cos 60, okay, and then plus D, which is just 1.5 sine 60 minus 1. So we close this. All right, then we bring in that other stuff, 400 times 1.5 times 0.75, then divided by answer. Okay, so B, we are getting a 310.58, right? And this is in what units? This is in newtons. So now let's find the vertical component. So we'll say summation of forces in the y equal to 0, like that, going up in our reference. Okay, so let's add some vertical components here. We're going to have a vertical component there. We'll have a vertical component like so, and then we'll have a horizontal component like so. Okay, so we know that if we have this line like this here, okay, and then we do have, let's say, this like so, we know that if this is 60 here, if this is 60, okay, this becomes 30, therefore this one here will be 60, right? Is that okay? That should be fine. So if this is 60, this is 30, this will be 60, the other one will be 30, like so. Great. So let's replace those angles then after establishing this. So we know therefore that this angle here is 60 degrees. And if that is the case, therefore this is just going to be equal to 400 by 1.5 cos 60. And then this one, this one is just going to be equal to 400 by 1.5 sine 60. Okay, so there we go. So then let's sum up the forces in the y. So we have AY plus B, this one, okay, B 1 over root 2, and then we have this one here, which is minus 400 by 1.5 by cos 60 equal to 0. And therefore our AY is just going to be equal to, let's work it out. Our AY is equal to, let's find what this is. Mind you, we've already found what B is, so you can just plug in this there. So we have 310.58 divided by root 2, okay, minus 400 by 1.5 cos 60. So AY is just equal to 80. AY is equal to 80.39, okay, newtons. Okay, then of course is in the same direction. In the same direction is going up. All right, and this one B is going in this direction like so, okay, which is 45 degrees. Then AX, we'll say summation of forces in the X direction equal to 0, going in this direction being our reference. What do we have? We have AX minus B by 1 divided by root of 2, and then we do have a plus 400 by 1.5 sine 60 equal to 0. Therefore our AX is just going to be equal to, we know what B is, just feed it in, to say the B, this B here is equal to, already, the B there, this one there, just feed the B in there. So AX is just going to be equal to 310 by 4.5 minus 310.58. So the BX that we used was this one here. I mean the B is that one there in the horizontal direction, divided by root of 2 plus 400 by 1.5 sine 60. So this one we get a minus 300 point, I think 00 like so, newtons. Okay, so this is 310.58 minus 310.58 divided by root of 2 plus 400 by 1.5 sine 60. So this becomes a 300 the other direction. So we can also write this as equal to just 300, okay, and it's going in that direction. We had assumed in this direction, but it's going in this direction like this. Alright, so this is about it. We have found B. Like we said, that member BC becomes a two-force member because of that force is not there. Immediately that force F, if F had a value which is not 0, then that could have ceased to be a two-force member. So right now it is a two-force member, which makes the problem much simpler. So we have the reactions at A and at B. Alright, I think this is about it. We have found what we are looking for and their directions, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, see you in my next screencast.